Thank you for joining and attending this webinar. We have a lot of registered participants, so we're going to wait a few minutes at the very beginning so that everyone has the time to join. But in the meantime, glad to have you here and hope you will enjoy it, of course. Remember, do not worry about notes or questions. We are going to record the webinar, so no problem on that side. And we are also going to give you time for a Q&A session. So you will have the time to ask all the questions, curiosity you might have. You're completely covered on that side. I see a lot of people coming. That's great.
Hi, everyone from my side as well. Nice to have you here. Emil, let me add that if you have any technical issues with audio or anything, just feel free to use the Q&A and our colleagues are going to be helping you to fix that as well.
Absolutely. Let us know any issue you might incurring into. We really want you to follow every single step of the webinar. So if there's any issue incoming, feel free to tell us and we will see how to solve it. We do have a team ready to intervene in case. Great. I'll say that we can wait 1-2 more minutes and then we can start and actually start the presentation. Perfect. And great. I hope summer is not also leaving on wherever you are connecting from, since cold is coming and winter vibes are coming, and that is now very pleasant. So hopefully you're still a bit in a summer mode wherever you are connecting from. Great. Let's wait. I'll say just a couple of seconds more for the latest ones to join, and then we can start. Okay, I see that pretty much everything is on track. I see a question from Igor. Yes, the recording of the webinar will be available, so no worry about that, indeed. And if you have any questions, of course, in the meantime, feel free to ask. We will leave a Q&A session at the end of the presentation, but if you have any question, feel free to ask and we will read it out loud at the end. Great, then I will say we're all set and we can start. Well, first of all, as I said, welcome everyone. We are glad to have you here live with us. And as you can see from the very first slide, we are going to talk about how to optimize solar and BESS projects in the Balkans, of course, with the RatedPower software. Just before starting the presentation, however, I would really like to thank Balkan Green Energy News for supporting us in hosting this webinar, for the outreach effort. It was an incredible organization. So thank you so much, guys, and the editor-in-chief, Branislava. And also introduce your speakers today, my colleague Matteo and myself. I will start off and then leave the floor to Matteo. I'm Emil Trepin, account executive at Enverus RatedPower, specialized in business development across Italy, but of course, CE and Balkans as well. Matteo, if you want to say something.
Thank you. Hi, everyone from my side as well. Welcome. I'm Matteo Menazzi, and I work as technical advisor for the same regions. Technical advisor on RatedPower is basically a team of engineers, and we support companies both to test RatedPower, so to approach and understand what we can do, but also we take care of the onboarding and customer support of our clients in the region. Specifically, I'm an electrical engineer, and I will be leading the technical session in a couple of minutes.
Great. Thank you, Matteo. Indeed, we will start off, as you can see from the agenda of the webinar, with what is RatedPower by Enverus, so who we are very quickly. And then we're going to also dive a little bit deeper on why the Balkans, why we do think the Balkans are a very interesting and fast-growing region for the solar and battery storage market. And then we are going to go to the main part of the presentation where my colleague Matteo is going to actually show you a demonstration of the RatedPower software and then wrapping up with the Q&A sessions for all your questions. Starting off with the very first point of our presentation, what is the RatedPower software by Enverus? Who are we? Well, in order to understand what we do and why we were born, we need to go back a little bit to the challenges that are very common across the region and that many companies are experiencing in the solar and BESS sectors. I'm not going to dive deeper into all of these challenges, but I do believe that some of you will probably familiarize with them. You're probably encountering them on a day-to-day basis. And these are fundamentally the reason why we were born, to support companies that are experiencing these challenges. And believe me, I'm telling you this already straight away, you're not the only one experiencing these challenges. These companies that you see here, indeed, were also experiencing the same exact challenges and issues that you're probably encountering in your day-to-day activities. And that's why they chose us as trusted partners to develop their activities and grow together. Here, as you can see, we have a plethora of companies that are our partners, developers, EPCs, manufacturers, even companies that are not really renowned to engage a lot in the solar sectors, such as Samsung, for example. But this slide really is an invitation for you, an invitation to join a community of success, a community of satisfied users that do partner and engage in talk with us on an everyday basis to bring their companies to the next level, which is exactly what we want to do with you here. What do you need to know about Enverus and RatedPower? Well, I'm going to give you a very quick sneak peek here of what our solution offers and the benefits that we can bring to you. And then my colleague Matteo is going to actually show you live how the software works. All you need to know about Enverus RatedPower basically is that we are the leading cloud-based solution for the design of PV and BESS plants. And I want you to remember three things about this slide, really. Three keywords. Fast, because we do provide the fastest simulations in the industry, reducing up to 90% the engineering time. Profitability, because our customers have experienced a 20% increase in the profitability of their project. And third, documents, because we do provide more than 400 pages of ready-to-use documents, bill of quantities, single line diagrams, business plans, and many more. So as you can understand, RatedPower is much more than a simple engineering tool. It can be used by any person in your company, and it is really a decision-making tool. Indeed, we're the only cloud-based solution in the market, so in the entire market of solar and battery, that integrates design and engineering, energy yield, and financial analysis. All this in one single platform. So probably the most comprehensive tool you can find available on the market. However, you're probably wondering, why did we choose the Balkans? Why we do think the Balkans are interesting? Well, as you probably know already, the Balkan region has been one of the fastest growing regions in Europe in the last decades and years, driven by energy transition and grid modernization needs, but also by investment momentum and a lot of public policy support. I cited here some data from the Serbian government. I know that a lot of our attendees are actually from Serbia, so you're going to be familiar with these data here. Well, as you can see, there has been a lot of effort by the Serbian government to allocate funds for the developer of solar and BESS capacity, but also to expand the renewable energy capacity, which increased to 3.9 gigawatts in 2024. Moreover, the high scalability due to abundant land availability, but also low development costs, clearly create a good environment for long-term partnership and the need for energy independence. And that is exactly why we are here and why we do support companies in the region like yours. Now, going into the main part of our presentation, my colleague Matteo right now is gonna deliver a demonstration of the RatedPower software. Hold off your questions a little bit. We are gonna leave a Q&A session at the end of the demonstration for you to ask any questions, doubt, or curiosity. And now, even though we are virtually, I'm gonna leave the floor to my colleague Matteo for the presentation.
Thank you so much, Amil, for the introduction. Let's get to the technical stuff. I guess all of you are very curious to see what's next. So first of all, the aim of today's webinar is going to be to give you an overview and a little bit of understanding of what we can do. Of course, we cannot delve into every single feature in detail. First, because it's going to be very boring, and second, because we don't have the time. So we will try to stick to the most important parts, but of course, shoot all the questions you have. We will have 15 minutes at the end to address those. So as Emile said, RatedPower is cloud-based, so you can access from any browser. I'm using Google Chrome, for example, and it's used for ground-mounted PV plants. So we are talking about 1 megawatt above. We can go up to 3-4 gigawatt without any problem. And hybrid system, that means storage plus PV, and finally storage only, the standalone storage solution. And we can see how these three things interconnect with each other. The tool is also multi-user. That basically means that more than one people can join the session and the tool at the same time, working either on the same project or on several different projects. Why did we come up with the idea of having such a software? That was to speed up, automate the design of PV plants and storage solution, because we see a lot of clients in the industry that are losing a lot of time to create proposals, to do the preliminary design, and they don't have that time to build a pipeline and do quality work. So we want to do whatever it's boring for engineers and let them do the cool, precise stuff that they like. So first thing, we are inside this project folder called Serbia, and what you can see over here is what we call designs. Those things are basically variants of the same project. Because we are so fast to do these designs, we can create as many as we wish and compare them to see how they perform once again the other. One real example, we compared an AC coupled BESS with a DC coupled BESS, and we can see how their performance is changing. Let me show you very quickly. So these are already run simulations, and I can click on this comparison table to address the most important KPIs of these projects. And I can choose between produce power, produce energy, equipment that I'm using, or financial parameters. So I have all these things together to see at the comprehensive level which kind of proposal is the most performing one. And that is useful if you are a developer, just to select the most optimal solution. But even if you are an EPC and you want to create different proposals for your clients, then you can create different scenarios and just let your client choose whatever they like more. That said, let's see how we get to one of these designs. So this is the main interface that you will be using. It's very easy to use. That's at least what our clients say. And on the left-hand side, you have all the main inputs of your simulation. That is basically where you will be working to customize the simulation, while on the center and the right-hand side, you have the main results. Let's start with the workflow so you understand what is the typical workflows that you are going to be seeing. The first thing you need to do is define the location. That means defining where your PV plant is going to be built and what are the available areas for you. In this example, I have one available area in white, some restricted areas in red. Those are all the things that you don't want to use for the PV plant. That could be roads, buildings, forests, archaeological sites, overhead line, whatever you want to exclude from the design. And then in black, we have an area dedicated for the batteries. And here I've added also a medium voltage switchgear to collect all the power. Now, these elements can be defined manually. So you can just, define this polygon like this, or you can import them as DWG files, KML, KMZ, or shape files. So that depends pretty much on what company profile you have and what type of process you follow, but you have all these options. After doing that, you will end up with something like this, right? We have empty polygons that we need to fill. So the next step would be selecting the equipment. This means basically deciding what I want to put in my PV plant. And that means selecting a module, an inverter, a structure, and the power station type. All of these can be selected from a database. So we provide pre-filled database for our clients, and they can just come here and select whatever they like. And this is pretty cool because you can run a simulation, for example, now using Jinko Solar solution, you run it. Everything else that we haven't touched is based on recommended value. As you proceed with the simulation, you can customize more values and get results which are more and more precise. But the cool thing is that in a couple of seconds, the software is going to provide you with the results, and you can assess the results while you are actually working on your simulation. So that's the pretty cool thing. As you can see, in a couple of seconds, the software has generated my layout. And over here, I can see the power AC and DC one that I have. But let's say that now I want to see how that is going to be performing with a different module. So I can just come here. I can pick a different module. Let's put, for example, let's pick something a little bit bigger. For example, this tongueway here, I can select it and rerun the simulation. And now I will have the updated results with the new variant. So for every parameter, you can use this kind of approach, which is pretty cool because it allows you to do something that you normally would take hours or weeks to do in a couple of seconds and really iterate and get to the best result possible. In here, besides the modules, you can work with different inverters, different structure types. So tracker, fixed structure, east-west structures, and also different power station solutions. The next step would be the layout part. So once you have selected the equipment, you need to tell the software, how do I place this to create the layout? And I know some of you already sent us a question asking, can I get a layout? Of course you can, and it's gonna be customized based on these parameters that you have here. Just a couple of examples. You can customize the distance between the structures, so the pitch distance. You can customize the type of internal roads that the software is going to place automatically for you. And those are typically visible here in the overview menu. In this case, I'm working with the no road option because the site is pretty small. But you could decide to have, for example, a full perimeter road, and you will have it over there. Other things you can do here, customize all the distances that you have around your PV plant or around your restricted areas. So all of that would be available from this folder over here. In the topography tab, what can you do here? Here you can basically analyze the slope in different direction and remove part of the PV plant where the slope is too high. So this is as simple as putting a value over here, and the software immediately is going to identify an area where the slope is too high, and it will be removing that from your simulation. In case you want to estimate the cubic meters of terrain you have to move to accept more structures and have, for example, a higher limit of 20%, you can do so, and the software is going to estimate that value for you. You can see here in this kind of orange color, you will have the fill volume and cut volume for all your PV plant. The idea here is that you can estimate, okay, if I want to build on this piece of land, I need to do X amount of earthwork and how much is going to cost, and you can analyze if it makes sense or not to address that cost. In the grid point tab, you can customize the way we interconnect the PV plant to the grid. And basically here, the interesting part will be customizing your voltage level. In case you are connected at high voltage level, so you will having a substation, the software is going to size the substation for you as well. And you can decide and customize under these parameters over here, the way the substation is going to be sized. Another question we got from one of you before registering was, is the software going to take into account the losses I have to interconnect to the grid? And the answer is yes. You can define an MV cable, an underground cable or an overhead line to connect to the grid. And you can customize in these two menus the way they are defined, so the circuits, the distances, and so on. The software is going to first size those elements for you, and secondly, calculate the losses you will have along those lines. In the electrical part, the most interesting part will be deciding how to place the strings on your tables and how to size all the cables. If we go in this overview tab over here, we'll see that the software can generate the low voltage AC cables you can see here in this color that are connecting to my transformer station over here, the MV cables in orange that go to the MV switchgear, but also the string cables in yellow. So you will have all these cables that are sized based on voltage drop that you customize over here and current carrying capabilities of your cables. In turn, you will get an Excel file with all the length and cross-section of each cable. Talking about results, I've shown you the 2D layout. We also have a 3D layout over here, which is basically placing all these elements in space to create this 3D layout, which is super appreciated, especially when you need to present your work to your clients, to investors, because it's very easy to understand and very visual. Besides from the power that I was mentioning before, you will have the power injected into the grid, the energy produced by the PV plant, the financial performance, which means the cost to build the PV plant, the main financial metrics, information about the storage system and the energy from the batteries. But I will go back to that in a bit. The last piece of documentation is the results, sorry, is the documentation, which is very appreciated, as Emil mentioned in the introduction, because it's going to save you a lot of time. You don't need to create these reports every time manually. They're going to be created for you, and you can just customize them based on what you need. You will have a couple of reports that are typically good for permitting reasons. Then you have a power flow model that you can use in software like Dixilent, ETAP, PSSE, so to run power flow analysis and short circuit current calculation. So basically the electrical network from the tool is going to be implementable in those tools automatically. So you don't need to waste time to do that manually. Then you have a lot of Excel files. For example, the bill of quantities, super interesting, especially for EPCs. The energy yield results hour by hour, the battery energy results hour by hour, the listing of cables that I was mentioning, the listing of all the piles, and the trackers with their location. That's good for construction. And then you have drawings in different formats as well, AutoCAD format, PDF format, 2D and 3D layout, are always exportable. The 3D scene in case you want to export to PVSys. Single line diagram, great for grid connection request, interconnection and storage facility, and SLD. So as you can see, there is a lot of documents you can leverage to speed up different stages of your workflow. Let's go now to see the very interesting new part for many of the companies, which is the storage piece. The storage part, as mentioned earlier, you can run 3 types of storage. Since now I'm looking at the PV plant, I can choose between AC coupled and DC coupled. First of all, what is the main difference? An AC coupled system is using and coupling the PV plant and the BESS plant at medium voltage level. What does it mean? I have here a transformer station for the PV from low to medium voltage. And here in green, I have transformer station for the storage system, and they are connected here at medium voltage level. This means that I will have dedicated inverters for my batteries and also a dedicated area. For the DC coupled, let me open up a simulation I already have here for the DC coupled. For the DC coupled, as you can see, the battery container, these blue containers, are placed inside the PV field and are using the same transformer station and the same inverter for both PV and BESS. All right, so that's the main difference. If we look now into more detail for the AC coupled one, you can choose, first of all, the equipment, which will be the power conversion system, the battery container. You can always select those from a database. So storage inverter, number of storage inverter. This is the case for the Sungrow Titan solution. So we have 12 inverter per transformer station. Then we're going to be selecting a battery container from the database. So that is always available. In case you want to use something custom, you can do so. You can specify the requirements. So if you want to supply a specific amount of hours, a specific number of BESS blocks or just fill the area with as much capacity as possible, and then customize the layout in terms of physical size of your elements, distribution of elements within the same block. You see I'm using this type of distribution here, and of course the distances between all blocks to be compliant with firefighters regulations in many countries. Then I can customize the roads in my storage system and their width. And finally, the dispatch part, which is the most interesting part for the people that are interested in the energy part, because in this menu, basically you can specify the behavior of the battery for charging and discharging. The option that we have at the moment is based on arbitrage. What does it mean? The software has an optimization algorithm that optimizes the charging and discharging to maximize the profit. How do we know what the profit is? Under the financial menu, we have a section which is called revenue, where you can decide if you want to have a fixed price or a variable price. In case of variable price, we will upload for you day-ahead prices for your market. In case you want to upload something custom, you can do it from here. Now, the software is going to look at that price and see when it's more profitable to sell the electricity. Let's make an example. Let's say you produce power at 11 in the morning and the price is low. It's not convenient for you to sell to the grid. You're going to be storing that electricity in your battery and sell to the grid maybe later in the evening when the price is higher. So that is the main principle. You can always decide if you're going to be charging only from the PV or also from the grid. The other thing you can take into account is here under power requirements is the energy clipping. In this example, we are producing 3.4 megawatt of power. You can say, hey, you cannot inject into the grid more than 2. So you can even consider grid limitation that you might have by your grid operator and see how the system is going to be performing, taking that into account. So that's the dispatch. The software based on this is going to give you hour by hour how much energy you have inside your battery, how much you give to the grid, and how much you are charging from the PV. The final piece will be the financial. We already saw the revenue. The other thing I wanted to show to you is the CapEx part. This is super interesting because based on this, the software is going to estimate the total price to build the PV plant. We provide standard templates based on the Renewable Energy Agency templates that they provide for some countries values that are based on kilowatt peak. So they have a standard structures and based on kilowatt peak, they provide you these prices. That's for PV. For the storage part, we provide prices from NREL. This is just a starting point for you. You can always easily create new templates that are going to be present in this private folder where you fully customize the structure, selecting, for example, a price per module, per BESS container, per meter of cable, and you can go as precise as you wish with whatever type of currency you want. So as you can see, the software provides you with standard values, recommended ones that you can use very easily, or you can customize to get more precise results. Now, let me show you quickly the DC coupled one that I mentioned earlier. The principle is very similar to the AC coupled ones. The difference is that once you select DC coupled, you don't have a PCS system. You're just going to be specifying the characteristics of a DC-DC converter that is connected to your PV inverter. And after that, everything else is basically the same principle as before. For a standalone solution, you have a dedicated interface. You are going to be designing a new design and you're going to be doing a standalone solution, which is very similar to what we saw earlier with reduced information because you don't have the PV part. But at the end of the day, the core part for the storage is exactly the same. Simply, it's related only to battery and you don't have the PV part. Other two quick things I wanted to mention. First of all, once you get your results, it's possible, especially if you are interested into the detail engineering part, that you want to customize the way we provide the layout because this is automatic. It's great for the initial stage, but when you move into more detail engineering, you might want to customize this. You have a specific function which is called edit layout that allows you to interact manually with this layout to customize it. you can interact with structures, roads, and power station to move things, create things, or delete things. Quick example, I can take a couple of structures, move them around, delete them, or add new structures. The same goes for power station and roads. After doing that, you're going to generate the design, and the software is going to create this edited version, which is based on your manual modification, but all the documents, all the results are now created automatically based on your manual modification. The very last thing, and this is a super cool, especially for companies that are want to speed up their process and hire new people, all the inputs that we saw can be saved as a template. So here on the top right, you can save all those inputs in a template. And then when you create a new project, you just need to define the areas, right? But then you just go under preferences, templates, and you load the template that you have created before with those specific parameters. For example, this one I use in Romania. I can load it. So all those parameters will be loaded, and then I can simply run. So now you can really see how a process that traditionally could take days, we can reduce that to a couple of seconds. So that is the main, let's say, reason that the software was built for, to save time for you. I would say that was all, and we have 13 minutes now for questions. So let me go back here. I really thank you all for the attention. I see there are a lot of questions, so I suggest we move directly to them. Just in the meanwhile, I'm gonna leave you this for you guys while you are typing, that in case we don't have time now to go to all the questions, if you want to have more information, just feel free to reach out to us. You have our contacts here. Emil, I don't know if you want to add anything that I missed.
No, absolutely. Thank you so much, Matteo. And as you were saying, in case we won't be able to address all the questions, don't worry, we got them saved and we will follow up with you in order to answer them. And of course, in case you wish to have any more, let's say, in-depth knowledge of the software, these are our contacts and feel free to reach us out. But let's move to the questions right now. I see already questions, the very first one asking if we can have a demo version of the softwares and if we can know the prices of the software. That's a very nice question to start with, and I think I can take this one. So usually what we do in our processes is that we do provide a personalized demo, meaning that we are gonna build a project of your own all together, and then we will share the outputs with you. In this way, you will have a tangible idea of the capabilities of the software and whether they fits the needs of your company or less. That's the whole idea. And this is going to be very efficient for you because you can see it in real time. As for the pricing, of course, as you know, the pricing is tailored depending on the functionalities and the subscription you choose, as well also as the size and the number of users of your companies. We do have companies that are paying insanely crazy amounts, going up to 100K, but that will not be the case for most of the companies that are going to be here. So we can have a chat absolutely about our pricing, but don't be scared because we do have very tailored solution, and we are very used to work with companies in the Balkan region. So we know also what are the market standards there. Hope that I answered the questions. Of course, these contacts we left here are also for you to reach out to us and schedule this personalized demo with us and get a better understanding of the capabilities of the software. I see another very interesting question here. Does the software have a sensitivity analysis tool built in to compare parameters for the plant? This one, I guess I will leave it to Matteo.
Yeah, absolutely. Thank you, Emil. So the tool, it exists, and it's one of the main, let's say, feature of the tool. As I was mentioning at the beginning, the idea is that you can select whatever parameter, then you create your simulation. Once you are in this type of view, you can simply select the variant that you want, click on compare, and it's going to create the tables that is customizable, as I was mentioning. this is exportable, but also charts. And the charts are great for doing that kind of sensitivity analysis, because here you can switch on or off different type of charts and see how specific parameters are influenced, especially energy output and financial performance. So that would be the main way to do that sensitivity analysis. All right, Emily, I think we can move to the next one, because I see a lot.
Indeed, I see a lot of them coming. Can we use the software for roof planning?
Yeah, I'll take that as well. No, the software is only for ground-mounted PV plant. We do have some clients, especially in the region, that they have some kind of hybrid system where they have part on the roof, part on the ground. You could use something simulating a roof if it's flat, like like a big flat building, but it's not developed specifically for rooftop. Okay, but if it's big enough, talking about around 1 hectare, you could use it, let's say, but it's not ideal.
Great, thank you, Matteo. I see another question related to the scope of the software. As I understand, the software is used in the project and design stage of a project. Is it also used for the operation of the plant after it is functional?
Right, I can take that one as well. That is correct. The tool is only for designing the PV plant and the project stage, not for optimizing when it's built. So it doesn't do like energy management for actual real PV plant. It's for before you build it.
Perfect. I see this other very interesting question related to actually BESS, whether is it possible to automatically size the BESS in megawatt and megawatt hours, depending on the capacity of the PV power plant and the functionality of the BESS?
That's a great question. Actually, we were discussing about this with one of our product manager this morning. At the moment, let's say the workflow that we have is that we allow our users to run multiple simulation to pick the most optimal for them. So it's more change the parameter, check the results, adjust the inputs, do it again, and get whatever it's optimal for you. So at the moment, the software doesn't automatically provide an optimal solution, but you have to tweak the parameters to get there. But it's something that we are considering for the future, because we know it's something highly requested.
Right. Thank you, Matteo. And I see this question that is really important. We know topography is a great concern in the Balkan region. How does the software consider topographic characteristics of the area, like altitude, isobars?
Perfect. So that's a great question. The topography is gotten from the location tab over here. We automatically get data from Google Earth, but this is always a starting point for you. You can always upload as a point cloud custom topography, for example, drone imagery or whatever custom data you have. And based on that, the software is going to run those analyses that we saw earlier under the topography tab over here.
Great. Another one related to pricing and CAPEX and OPEX. How often are the assumed CAPEX and OPEX prices per country updated?
Yeah, so that, as I was mentioning, the default ones, they come from the IRENA and NREL. So we update them once a year when they release the new reports. But just pay attention, that is not for all the countries. So the way that IRENA works is that sometimes they update that specific country every year. Sometimes they don't. It depends a little bit on the situation of the market. So typically it could be updated one or twice, like every 1 or 2 years, depending on the source. But in my total honesty, if you're interested in a financial analysis, you should definitely create your own template, customizing those values. Those that we provide are just meant for you to have a general starting point idea.
That's great. Going from financials back to more engineering related questions. So let's go to inverters. In the section for inverters, is it possible to select between string and centralized inverter arrangements? How can centralized or array inverters be configured?
Right, great question as well. So under the equipment section, you can decide if you want to have a central inverter or a string inverter. If you have a central inverter, you always go to the database and you pick whatever you want. And you can also add a secondary inverter that is typically like a smaller size inverter, right? So you can combine these two types of inverters and the software is going to automatically distribute them to match the required power. For string inverters, is simply selecting the string inverter you wanna have from the database. Just as an information, in case of a central inverter under the electrical part, you can also customize the size of your stream box from this drop-down list. So the software is going to automatically assign strings to stream box to inverters for you automatically.
Great, thank you, Matteo. Thank you for the question. What about battery containers? What about the spacing between containers? Is there any safe distance?
All right, so this the spacing between containers, let me get to the AC coupled example here. It's one of the most important parameters that most of our clients are looking into, and you can customize that under layout block distances, basically these parameters here. As you know, there are two things to bear in mind. Manufacturers might recommend some safety distances, but most often the most restrictive regulations are from specific countries, municipalities, or regions that force you to respect some distances. So you just need to know what are those requirements and add here the relative number, and it's as simple as that.
Perfect. Thank you for the question. Another one on the scope of the software. We partly covered that, but it's good to refresh the memory. Can rated power be used for smaller systems? For example, ground-mounted PV plants less than 1 megawatt or rooftop projects between 100 kilowatt and 1 megawatt and storage system for them?
Right. Yeah, that's a great question. And I know that in the region it's something that is it is common. So we typically recommend to use the tool for a system higher than 1 megawatt. You can totally use even for smaller system, but you need to be aware of one thing. First of all, the software will always define at least one transformer station. So you're gonna be always connected at medium voltage level. And of course, the power of the tool, you perceive it more when the system is bigger, of course, because it's going to be like the time that you spend to do something manually is drastically larger if the system is larger, right? If the system is super small, you don't perceive that much as an advantage. So what I would say, if you work between 500 kV and above, it could still something interesting to talk. If it's below the threshold, I think it's not the right tool for you.
Great, thank you for the question. Important to remind it. And a little bit more again into the financial part. What are the key financial performance indicators considered by the software?
All right. Well, today a lot of great questions. So we have them here on the right-hand side. So we have the specific price, both for PV battery, the LCOE, so the levelized cost of energy, the NPV, the IRR, the ROI, payback, and discounted payback. You can see this as a number, but also click here and see the graphical evolution of the system in time. So you can really understand what's happening. In this case, you can see with default values, this PV plant plus storage doesn't even break even. And we know that this is an issue that typically without incentives, it's hard to get a storage system to a financial feasible business plan. But of course, it depends on the cost of the PV plant in the region, electricity prices, and so on and so forth. That's why I was saying it's very important for you to customize this value with real values that you're gonna be using in real life.
Great, thank you for the question. Meteo dataset, winter is approaching, so Meteo is important. What Meteo dataset is used to carry out the yield assessment?
Right, so by default, we will provide PVJS data from SERA 3. And that's, you can see here is PVJS 5.3 as a TMY. We do provide by default also NESA power, NESA SSE value. So those are always going to be available for you. Anything else can be either directly integrated using API, and you can see Solar Anywhere, Solcast, and SolarGIS, or uploaded manually. Manually, you can even go sub-hourly up to 1 minute. So that's, as usual, up to you.
Great, thank you for the question. I see we're running out of time. We have time for 2 more questions. Is it possible to dimension and make a layout of a PV power plant, also depending on the outcome of glint and glare study?
All right, that's also a good question. So you can, let's say, design the PV plant starting from polygons, right? So as long as you have a software that provides you with areas either in DWG, KML, KMZ, or shapefile, you can get those areas into the software and use those to run your simulations. All right, so as long as you have that, you should be able to use other tool in the, let's say, even earlier stage to do some prospection or a restriction analysis.
Great. Time for one last question. You are the lucky one. Following your demo, it looks like the system can be used even by non-technical stuff. Could you clarify whether users are typically engineers, designers, or whether the system can be used as well by non-technical stuff?
All right, well, that's a great question as well. I think, Amil, you could also help me with that. But in our experience, it can cover both, because the fact that you have recommended values, but also higher degrees of flexibility depending on your profile, you can be non-technical, so use more the templates and recommended value and get just pre-feasibility information, or be a very technical, so an engineer, and go and tweak all the different parameters. And that is also the core of collaboration. Within the same company, the early stage can be done by somebody that is not technical. So you don't waste, let's say, an engineering time for maybe a project that doesn't go anywhere. Once you know that project is yours, you can have an engineer review those parameters and get into more details.
That's great. Thank you for the question. And if I may add, I know that a lot of the people connected here are part of EPC or early developers stage companies. Well, what I can tell you is that within our company as well, the sales team can utilize the tool without any problem. So as you can see, compared to a standard AutoCAD, is really user-friendly and adapted to any professional figure that you might have in your team. Having said that, I guess we are running out of time, and this was pretty much it. I know we couldn't answer all the questions. There were a lot of them, but don't worry, we are going to follow up with you. As I was mentioning before, please reach out to us. You have our contacts here. Let's schedule a demo, a personalized one with your team. Let's get deeper into what the software can benefit you, how we can support you, and we will be more than glad to have a deeper conversation. Feel free to reach out to us. It has been a pleasure to host this webinar. Thank you for connecting, all of you. So feel free to connect with us, and I'm sure we're going to find a way to support you and help you grow and become partner. Once again, thank you so much for connecting, and I wish you a pleasant rest of the afternoon.
Thank you, everyone, from my side as well, for the attention, the questions. I really hope to see you soon. Have a great rest of the week. Bye-bye.
Bye.